Good evening, everyone. This is Christian Roberts. I'm back with another video, and today we're going to talk about immunosuppressive drugs and the mechanism of action. So, before I begin to go further into detail, I want to kind of just give a specific description of what an immunosuppressive drug is and what they're basically classified as pharmaceuticals that can act on a variety of different pathways regard when it comes to knocking down the immune system. It is basically helpful for people who have organ transplants or fighting autoimmune disease, or sometimes non-autoimmune disease like that are like inflammatory, like such as asthma, and also the immunosuppressive uh drug also suppress certain enzymes like calceronium. Like, for example, we are going to get into depth once there's a diagram in this presentation. So I'm about to move forward. So so pathways targeted by immunosuppressive drugs. We are going to talk about the overview of the target specificity and identifying the targets and the function of it as well, honestly. So So when talking about the inhibition of the pathways, the immunosuppressive drugs will interfere with a certain enzyme with the specific pathway. Depending on what pathway it is, it really depends on what the disease is, honestly. But as long as it's something that is affecting the immune system. So there are certain mechanisms and everything, and there are certain mechanisms, and one mechanism that I've researched is that they inhibit a pathway that targets key signaling molecules, which involves T cell activation. For example, calcineurin inhibitors like cyclosporine can inhibit the activity of calcineurin, which is a phosphatase enzyme that is crucial for the activation of the T cells. So what happens is, like, in order to prevent the growth of the immune system or the immune disease, they have to activate that certain enzyme that regulates, that basically takes that phosphate group off. Because, when it comes to phosphatase means taking a phosphate group away from an enzyme in a specific pathway. So with that, they have to take a phosphate. Due to the fact that they have to take the phosphate away, that means a kinase has to be involved in order to prevent that inhibition, honestly, in order for it to be inhibited. And then, like when I said binding to specific receptors, there are certain receptors, like I said, like there's going to be kinases that's going to be binded, and then there's going to be blockage of the pathways key enzyme, which is, like I said, calcineurin, which is a phosphatase enzyme. So once that phosphatase enzyme can't move at all, then everything else will basically die off, honestly. And it will basically prevent the dysphosphorylation of the nuclear factor of activated T cells, honestly. So this is all basically blocking T cell activation. And like I said, it's the photo on the mechanism of action of inhibiting pathways. Like I said, see how you see all the drugs down here or whatever. And notice how there's a protein kinase. Like I said before, a phosphatase is going to be inhibited. So that means the kinase is going to be activated. So once that kinase is activated, that means that the immune cell disease will no longer replicate or no longer be activated. So that means it will no longer reproduce itself. And see how I said the mechanism of action, like I said, calcineurin inhibitor is mentioned, and it's the phase 2. So it is right, excuse me for a second. It is right here, right here. And see the voclosporin, voclosporin. So that is one mechanism. And then there's other like mechanisms like the Janus kinase or the protein kinase. See, like I said, there's kinases involved too that can actually help with preventing T cell activation. So as I move on. So now we're going to talk about the immune system's downregulation and is the consequence of inhibiting the pathway, which is impact on immune cell function and proliferation, and the reduction of inflammatory responses. So basically, there are some before I'm sorry. Okay, so basically, obviously, like I said, the consequence before. So obviously, what happens when the enzyme is inhibited? T cell activation is going to be dephosphorylated. So that means that T cell activation, when you think of T cell, that means the lymphocytes and everything else around it is no longer going to reproduce and grow and divide. It's going to die. It's going to die. It's going to lose energy. That's the short version. So now, and now we have the supporting evidence. And I just want to tell you, there are some clinical studies that demonstrate efficacy, and there are also mechanistic studies that is elucidating the drug interactions, and there is structural and biochemical analytics. Obviously, like I said, there's a chart that I showed you before that is evident and kind of shows you and demonstrates where what specific enzyme is blocked and what is involved, what other enzyme is involved to prevent T cell activation, like the kinases. And this is my conclusion. So what we learned throughout this video is that we've implicated the methods for clinical practices, and we recap key points of the immunosuppressive drug inhibition and function, and we learned the future prediction and directive regarding immunosuppressive therapy. I do want to say this regarding future predictions. There are programs where they are programs. So basically, all I'm going to say is for future predictions, if you feel any type of pain, if you have any type of autoimmune disease, the best thing to do is actually go to a doctor that actually care about you and actually value how you feel and actually will get to the bottom and go and sit down with you and tell you exactly what you need. Because honestly, many antibiotics and medication regarding in this field tend to not work at the time because people tend to have a high dependency, and once the body has a high dependency on a certain thing, it will no longer be affected by it. So go to your doctor before you do anything, before you take over the counter meds, because they're the ones that can give you the proper exact amount of doses that you could take, just so you won't have to face this error later on. And now this is my resource cited and including the photo, figure 3, new immunosuppressant drugs. So this is the figure, and everything else is basically what I've told you. And this has been a nice video, and I hope that you enjoy the video and see you around. Thank you.